Parametric equation. Parametric equation. I love it. Parametric equation. Oh yeah, the idea, the concept. Alright? Allow me this master's video tutorials, please. Don't forget to subscribe. Okay, let's continue. Now, in the parametric equation, it's all about motion in a plane. It's all about motion in what? A plane. Alright? Okay, so you love it. So define motion in x and y what? Direction as a function of some what? Variable t over a common what? Domain. And that domain is what we call the what? The interval. Alright? You love it. The t is the parameter and the I is the parameter what? Interval. Good. T is typically thought of as the time. So the t is what we are talking to be what? The time. Or we are taking it to be what? A time. So for some interval, let's say a, b. It can be 2, 3, 4, 5, anything. So for some interval, an object starts from where? Rest, right? So that is the initial. So that's the initial. So your initial point, if you are having an interval, let me write it here. Interval, oh wow. If you are having an interval AB, your initial point is when I is equal to what? A. Sorry, when t is equal to what? A. Alright? So for you to get the initial point, is the time there. This is the initial point. This is the initial. This is the initial. And this is the what? The terminal. Alright, you will come there. So for you to get an initial point, you need the time A to get it, right? So the function of s in terms of t will be given to you, and the function of y in terms of what t will be given to you. So when you pick your t to be A, in the function of f, where you see t, put one there A. In the function of g, where you see t, put one there A, and that will give you a point of s, y. Beautiful. So please here, we are not going to use polar curve. We are going to use your normal graph to sketch this, and you will love it. Okay. 2. Terminal point. So the terminal point is where t is equal to b, and by substitution we get the point. So it all goes along a trajectory with a specific what? Orientation. So the orientation should be shown. Alright? So let's say I have this Cartesian plane, then I start moving, then I continue like that. So that means that my initial point is this, and this is my terminal point. So I have to show a direction. I have to show a direction to where I ended, obviously. So that is what? Along a trajectory with a specific what? Orientation. Alright, I'll be back with some questions, then we move on. Alright, welcome back to our first question and the parametric equation. Yes, and Nigerian man will say parametric equation. Alright, so let's sketch the curve defined by the parametric equation. This and that. So always you have to expect two things. You have to expect three. The function of x in terms of t, which is 2t minus t squared. Then the y in terms of t, which is t plus 4. Alright? Then you have to also be expecting an interval that will be given to you. So the interval is -2, 4. Right? So as we were saying, the interval, you see that this is the A and this is the what? The B. Alright? So for you to know your starting point and your ending point, is about you doing the substitution of this inside of this. Always clear. Let's try something before we go to what you want to do. So you see that we can pick the at t is equal to -2. This will give us the what? The initial what? Point. the initial point. So here our initial point is going to be s of negative 2 being equal to, so put negative 2 here, what will you get? Alright, so you get 2 negative 2 minus negative 2 squared, and this will give you negative 8. Then at y4, right? So that one to, sorry, y. So that one to where you see t, put 4 there, and that one will give you 4 plus 4, right? Okay. So here, oh, sorry. So, sorry, our t here is what? Negative 2, not 4. Therefore, is what will give us the terminal. So, negative 2. So, here we are going to get 2. Alright. So, therefore, we can get a point, which is the initial point, to be negative 8, 2. Alright? So this will be our starting point. Alright. So at t is equal to 4, we can also get our terminal point. I want to explain to you the idea I gave you before we come back to something. So at S4, we can also get something there, right? So when you do that substitution here, 2, 4 minus 4 squared. This one will give you negative 8. Alright? And y4, 2 will give you 8. Alright? So at that point, you are going to get negative 8, 8. So this means that this will be your starting point and this will be your ending point. So this is the initial point and this is the terminal point. So the initial and this is the terminal. Alright, so let's come back to the question. This is how you can get the initial point and the terminal point if you are asked for it. So you use the interval. Good. So now you have to state the curve defined by the parametric equation that. In the initial that. Good. So now, here we are going to draw a graph, right? So we need our values. So you start with this, okay? Alright, so now your time has to be defined. And what is the time? The time is the interval given you, right? That is from negative 2 to 4. So here will be the s being equal to 2t minus t squared. And here will be y is equal to t plus 4. Good, beautiful. Alright, so now this is what we are going to do. So lastly, we have to be getting a point of what? Sy. Shall take your calculator and let's go. So here, start from where? Negative 2. Then what will you go again? Negative 1, 0, 1, 2, 3, 4, 5. No, don't go to 5. Why? Because it's not part of the interval. So you cannot go to 5. No. Hey, Charlie, don't do that. Alright. So we should be within the what? The interval. Beautiful. So here, when you see t, put this there, get a value like that. So we are just doing substitution. So when you get negative 2 here, you get 8 here. Therefore, your point will be negative Therefore, your point, sorry, you get negative 8 here, 2 here, so negative 8, 2. Beautiful. Here you get negative 3, 3. So your point will be what? Negative 3, 3. Beautiful. Here you get 0, 4. So your point will be 0, 4. Beautiful. You get 1, you get 5 here, so your point will be 1, 5. Well, again. Alright. So here you get 0, here you get 6. So you get 0, 6. At 3, negative 3, 7. So here you get negative 3, 7. Here you get negative 8, 8. So here you get negative 8, 8. So that's why our first start, we have our initial to be that and our terminal to be that. So that's the initial, that's the terminal. Please, always don't take my own to be your final decision. Make sure you take your calculator, test also, and see what you get. Alright. So after getting this, our only thing to do is to sketch it. You are just to go and sketch this point. Alright? And you won't know how to sketch this point. And this is not a polar graph, this is just XYZ what? Or your Cartesian plane. Alright, so I'll plane it. Go, 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 go. Alright, we are back. So now, check your leg. Yeah, you're going to choose the scale you're on, alright? So, you can see that we have negative 8 in there. So for the x, you will need negative 8. Okay, let me check here. For the x, you need negative 8. Oh, there are negative numbers. That means that the graph, we have to limit the positive side for x, right? So the positive side for x, we have to limit it so that more will come to the what? To the negative what? Side. Alright. So here, the scale, we can make it 1, 2. In fact, we don't even have positive 1 there. Alright, so we can leave it like this: negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Serious. We don't have any negative value for s, so don't worry. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Okay, why? The y2, you can see that. The y2, you can see that, oh, they are positives. They are positive. That means that you will limit the negative of y's so that you can get more space here. Alright, so that you can get more space here. So that place to what we have there, up to 8. Okay, I should have put this one down small. Don't worry, I have time. I have time for you. It will help you to check when you are doing your own. So that you will not repeat my own, you will check before. So here to give you one. Beautiful! Yes, we did can see that. So negative 2 at s, 2 at y. That's why we normally say laziness is easy. Just do it and do the right thing, you are done. Negative 3, 3. Negative 3, 3. Beautiful. My own is not according to scale. 0, 4. 0, 4. 0, 4. Oh. Beautiful. Let's continue. What do we have here? 1, 5. 1, 5. 1, 5. Oh, so we will need positive 1 here, don't worry. Alright. 1, 5. That will be here. Beautiful. 0, 6. Oh. Negative 3, 7. Negative 3, 7. Negative 8, 8. Negative 8, 8. Beautiful. Beautiful. I hope you have seen what we are doing. Alright, so now these are the points. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. What is the other one? 1, 2, 3, 4, 5, 6, 7. Alright. So now we can start. So see how you are going to start it. What is your initial? Negative 82. So we start from here, negative 82. Alright. So let's see what you are going to get. So we start at negative 82 like this. Then your next point is negative 3, 3. That's it, right? Then you move to 0, 4. So where is 0, 4? 0. So you move to the 4. So just continue your graph. Then come to this side. Move to this side. Beautiful. 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 So it's going to be something like this. Oh, I love this. Let me clean it and do it well. Yeah, I've cleaned the point. Negative 3, 3. It's here. Alright, I want to do the right thing. Beautiful. So that's how the graph is going to be. But don't forget, this is the initial, right? This is the initial. So you show this. That is what? That is what we call a trajectory. So you show it. If you don't show, you are wrong. Show that. Show it. Don't do anything shabala. Show it. Okay. So from here it continues. So you show it. So that's how it's going to be. So this is going to be the terminal what? Point. Good. So that's going to be your parametric equation. See you for the next question. Alright, so now looking at this question, I hope you can see something. Given that, oh, something is not given here. What is that? The interval. So yeah, you don't know the interval, but you were told from the introduction that the interval is always the what? The domain. So you have to state the what? The domain. For instance, if you give me st is equal to t squared minus 4, y is equal to 2t. If I'm not giving the domain here, I know that this will work for all real numbers. There is nothing that you can do substitution here that you get it to be like a mass error. No. Whether from positive infinity to negative infinity or from negative infinity to positive infinity, anything that you put here, it will work for you. Is that not so? That means that your domain is negative infinity to what? Positive what? Infinity. So dealing with a question like this, that I would like you to continue with it. Here, you will choose your domain. Alright? You will choose any domain you like. So a question like this, you will continue with it. If the interval is not giving you, you can choose that. Okay, then I will choose my interval to be negative 5 to 5. Okay? Negative 5, I'm giving you the idea before I come to this. Negative 5 to 5. So that on the table, I'll start negative 5, negative 4, negative 3, negative, what is that? Negative 2, negative 1, 0, 1, 2, 3, 4, 5. But this is because this is negative infinity to positive infinity. That means that negative millions is part, positive millions is part. You can't do all. So you can restrict yourself to, no, don't make it close interval. Make it open interval. You can restrict yourself to this, alright? You will continue with this question. So that when you are done getting your x and your y, you will sketch it. But let's say that if you sketch, I know what you will get in this question, alright. Let's say that if you sketch, you will get something like this. Let's say that if you sketch, you will get something like this. So if you get something like this, it means that you will not show point here. If you show point here, it means that you were given the initial and the final. You will make it an open arrow like this, showing that it's going to it's coming from negative infinity to what? Positive what? Infinity. I hope it's clear. Don't forget that. So it's going positive infinity to what? Negative what? Infinity. So that's how you deal with such one question. Go and try on it. Alright. Now, from what is on the board, the interval is not given, don't worry. So what is the domain for these two? Not only one, consider the two. Now when you consider the one, you can see that any number you put here, it will work. Put negative time, whatever, it will work, right? So no problem there. But there is a problem here. Is it any number that you put inside of a square root that you can get a result? If you like put any positive number, square root of 0, you get 0. Square root of 1,500 million, you will get a result, right? But try square root of a negative result, negative 5. I hope you can see a complex sign there. If you try negative 7, you will still see a complex sign there. A complex sign there giving you something like this. Is that also? Alright. So that means that there is a restriction under this. There is a restriction. And the domain is, so you choose the domain. So you see that the domain is that x cannot be what? Equal to the negative what? Sorry, c cannot be equal to what? The negative what? Values, right? So the domain should be that interval t being greater than or equal to what? 0. Because if it's greater than or equal to 0, that means that it will work for all those what? Domains. Is that clear? Thank you for that. So come out with your table. So if you want to come out with a table for this, don't worry. You identify your t's, your s, and your y. So you start from 0. Start, that's all. Then you go. Now, this is not ending. Greater than or equal to, it's not ending. So you end at anywhere you like. Me, I don't like much work to do. So I'll end at 3. So by substitution, put this one here. You get 0, 1, 1.4. The reason is that if you add negative t's, when you punch on calculator to get a value for this, you will not get it. That's why you have to choose the domain. Alright. So 1.4, 1.7. Always, if you are getting it in a fraction, leave it in what? A decimal for you. So that you can choose your scale for the graph. Here will be 0, 1, 2, 3. So you know the point that we are going to have. 0, 0, 1, 1, that. Alright. Then you sketch it. So when you sketch it, I've given you the concept already, okay? So this is going to be something like this. Then you show your destiny, showing that it's going where? Infinity. Starting from here, going where? Infinity. So that's how it's going to be. Yes. So you show your let's say 1, 2, 3. 1, 2, 3. Then you do your graph like that, and that's how you're going to get it. Alright. See you in the next video.